right, so today we have Heiko Hotz and Sokratis Kartakis, both from Google Cloud. And we're here to talk about agent protocols, specifically A2A. And with that, guys, welcome to the podcast.
Thank you. Thanks for having us.
Thank you.
And so feels like we're in this Cambrian explosion of agents, right? So many frameworks, so many tools. So I guess the first question for you folks is why agent to agent communication? So, in other words, some listeners might think, well, maybe we should focus on getting single agent tooling working first. So why jump into agent to agent communication? So
Uh, well, as you can imagine, for the last many months, many developers they start developing agents with completely different frameworks, right? From LangGraph to Crew AI to ADK or Agent Development Kit, as we have in Google. And at some point, they want to link all these agents together. One way to do that is to go and start changing the code of your system, of your application, in order to accommodate all of them. So it would be much easier if all these agents can talk the same language, and it would be easier to incorporate them then by not changing your code, but by saying, "Oh, here is a new agent. Start using that." And this is where we start having the need of a protocol to make all these agents having the same language and collaborate together.
so hey Heiko, was in your impression, so was A2A something that developers were, so someone approached you folks for it basically?
Um, I wouldn't say that. I think it is fair to say, and I think your observation, Ben, is spot on that, we should maybe fix single agents first. But A2A is, I would call it a forward-looking protocol. In addition to what Socrates said, we do see a future, especially in large organizations, where one team develops an agent that does something, maybe a financial statement analysis or whatever have you, book you flights. And then another team within the same organization, or maybe even outside of the organization, would like to leverage that same capability. Now, an agent is just very different from an API. In the past, this was done via APIs. I provide you an API, you can use my service. Agents are more complex, but in order to provide this functionality still to others, either within my organization or outside of my organization, I need a different protocol. I need a stateful protocol where I can send a task and the task can run asynchronously in the background and give me status updates and perform what it needs to do. So that's, I think, the justification for the agent to agent protocol. Now, come back to your question. To my knowledge, no one has specifically asked for this, but I believe we will be there in a few months' time, right? The speed with which everything accelerates at the moment, I believe it's not far fetched to say in a year's time, for example, um, organization A or team A within the organization has developed an agent and other or teams want to use that, and how would they do that?
So right now, for people, developers in this space, obviously the most familiar protocol is the one from Anthropic, Model Context Protocol, which is a single agent protocol focused on external tool integration in some ways, right?
That's right.
So are we in? So what is the relationship moving forward? Do you think between MCP and A2A?
Yeah. Yeah, I can take this one. So we believe that MCP and A2A will be complementary and not, rivals in terms of protocols. And the reason for that is, as you mentioned, MCP is very specific to tools, an agent that wants to use a tool versus agent to agent protocol that really connects agents with each other. And that brings us to the question, which is actually not that easy to answer, is when do I wrap a functionality in a tool versus when do I wrap a functionality in an agent. But if we look at the technical implementation and dive deeper into it, that gives us actually some hints when to use which. So the way an MCP tool or tool in general exposes its capabilities to the outside world is via a structured schema. I need input A and input B, and I give you the sum of those two numbers, for example. It's a structured schema. I cannot deviate from it when I want to use that tool. It is also a one shot, a single interaction. I send you a request and you send me a response. If I wrap the same functionality into an agent, the way I expose the functionality is already different. A2A expects a natural language description of the functionality of the agent. So instead of giving a schema, I would have to say, this agent adds two numbers and gives you back the sum. Also, the agent to agent protocol, as I mentioned earlier, is stateful in terms of like I send you a request and then you can do whatever you need to do in the background. You can send me updates. And in the end, I get a result. So by looking at those two different ways of implementing functionalities, that will give us or developers a hint on like when to use an agent and when to use a tool to wrap a functionality. The analogy I like to use is a vending machine versus a concierge. With a vending machine, I give it the money, I type in what I want, I get something out. With a concierge, I might just say, I'm thirsty, buy me something to drink.
So actually, before so I have a lot of questions about this topic, but before we proceed further, maybe Sokratis, we can help our listeners kind of make this notion of agent to agent even more concrete. So one thing I kind of tell non-expert users is you're already using an agent to some extent, because whenever you use one of these deep research tools, that's kind of an agent, right? And then I started talking to other people who are building AI tools in finance, and they have this notion of, yeah, so maybe I want to do research, but then I have an agent go and look at agents' earnings transcripts, another agent looking at other pieces of data, and so on and so forth. So is that a concrete example of agent to agent, or do you folks have a canonical example that you use to explain or to make agent to agent concrete to non-experts?
Well, we can parallelize agent to agent protocol with real businesses. What I mean is, let's imagine that we have specialist agents that can be different employees with different skills. Each of these employees, or even consultants, let's say, they have their own business card, right? And then what they do is they share this business card with their clients. That means that the client, that is an application in A2A, can understand, okay, from all these business cards that I have, what task do I want to do? I want to learn about the stocks. I want to learn about the investments. In that case, I will call the right specialized agent or the server, as we call it in A2A, in order to get the real specialized answer back. And this is the whole idea behind everything. Each agent has a business card, share with others, and start using them whenever you need it. Each agent has its own skills. This is very important. Each agent has different capabilities. For example, I can talk to the agent with a live streaming, or I can send a message to the agent and can get a response back. So you need to define in real world, you have an agent that might have a phone number, an email, etc. So you need exactly this to define how you will communicate with this agent. And of course, because we like security, you need also to define what is the security method that you will use in order to exchange messages with your specialized agents as well.
We'll get to security in a second. So Heiko, so last year, yeah, late last year, people started talking about. So we were still in the single agent mindset last year, right? So last year, people were already talking about. Well, if we're gonna build agents all over the place. So what would be kind of let's imagine what the agent stack will be, right? So then they started talking about things like memory, storage, observability, and so on and so forth. So now that you folks are starting to talk about multi agents or agent to agent, are there important things that need to be introduced to the agentic stack, or that stack remains the same? You still have memory, storage, and all the things that you need.
You would still have the same. You would still need in arguably even more in an agent to agent system or a multi agent system. You need statefulness, right? So you would need memory. You would need access to tools.
Or is that going to be like a shared memory across agents?
It can be. It all depends on the architecture, really. The way I imagine a let's say a vanilla architecture, the way I imagine is the user speaks to a router agent, which is the primary contact of the user with the multi-agent system. And that router agent does very simple things like saying hello, how can I help you? But as Socrates described, once the user asks let's say, asks the multi-agent system, book me a holiday to Paris. There's many steps involved, right? You could imagine then behind the router agent,
No agent can do this yet.
no agent can do this yet, but the capabilities
Are there?
are getting better and
Mm.
better. I would not be surprised in a year's time or 2 years that the multi-agent systems are out there that can do that. But so the way I imagine it is you have this router agent, which is the boss of all these specialist agents. And now you would have two or three remote agents or server agents that do different things. One looks after the flights, for example, and finds the flights. But then there is a hotel booking agent and maybe a car booking agent. And all these agents obviously need to know from each other, right? If the flight agent finds and books me flights from the 21st to the 28th, the hotel booking agent would need to know that. And the way I would imagine, again, in a vanilla, quite rather simple architecture is that the router agent holds the context for all of those. Uh, if you build it all within one agentic framework, like Google's Agent Development Kit or LangChain, then it becomes even easier because those frameworks have the concept of shared memory built in, but it's not necessarily needed, even if my hotel booking agent is built in LangChain and maybe from a different team as compared to my flight booking agent, then the router agent would still need to decide what information is needed.
Actually, what you just said there actually is the argument for why you need these protocols. If you're right, so if the hotel booking agent is using one framework, agentic
Yes, exactly.
framework, and then by the way,
Exactly.
your example is the canonical simple example. Because what if Heiko, if my trip involves four different countries, right? So so I need a hotel agent for each country, right?
Mm, potentially.
Yeah, because the hotels might you might need to specialize the agents for local knowledge, right?
Yes, to be honest, technically, you might not need to change agents or how you build the agents. Probably you need to change
The data.
which agent has access to what data exactly. This is very, very important. And I want also to add to what Heiko said earlier. We need to think a little bit to parallelize single agent with multi-agent systems. Like we move from a monolithic application with everything in one huge block to microservices that we have small dedicated agents to perform quite specific tasks. This has many benefits, not only benefits from a user perspective or building from a specific business unit or development team, but also it makes the life first of the developer easier because you can test, you can evaluate, you can perform different checks before you move to production with a much easier way. But also, it will be much easier. Let's imagine the scenario that you have an agent or a real human, right? And you give 100 tools to this human being to perform a specific task. Most probably, this human will get confused, right? How to use the different tools. It is exactly the same with the agents. You need to have small agents with specific tools in order to perform the right task for the end user.
By the way, so Heiko's example actually drives home the fact why something like MCP may not be enough, right? Because basically, if you had this master agent and all it was doing was like integrating with external sites, but the integration is not smart in some sense because basically, if the other side had an agent, that other agent could be thinking as well, right? So and
Absolutely.
that's why this agent to agent thing, while it's a bit of a science fiction at the moment, it does make sense moving forward, right? So,
We think so. And coming back to Socrates' point, which is exactly correct, that we also see empirically. Once you give an agent too many tools and try to make it do too many different things, right? If I just had one agent that is responsible for the flight booking, as well as for the hotel booking, as well for the car booking, it just becomes more and more likely that by reasoning through all these tools, it might just pick the wrong tool, which, gets us to the point also of evaluation and fault tolerance for these agents.
And at some point, we might see multi-agent systems communicate with other multi-agent systems, like an agent mesh, if I may say, right? In order to achieve even further scalability.
no, in the scenario of this hotel booking, where you have the master agent working with a bunch of other agents, in that scenario, each of those smaller agents would be using their own local model to some extent, right?
That's right.
It's not like they all rely on a central model.
No, not at all. I believe almost all frameworks, if not all frameworks, allow you to choose the right model for the right task. If a task is rather simple but still requires LLM capabilities, a even a local small open source model like a Llama model could be sufficient. If the task really requires like heavy, brain power, brain in air quotes, you might want to use a Gemini 2.5 Pro.
Sokratis brought up the word security. So let me talk about security here for a second. So one of the earlier, I guess, attacks against MCP is kind of this scenario where the MCP server, an attacker might bury instructions in the server side instruction of that MCP server or the metadata, which then gets sent into the model. But because it's coming from the MCP server, the model accepts it, right? So, but it might have malicious instructions. So in this case, I guess, you have the smaller agents, but the smaller agent may, something may happen to the smaller agent, and it may send something bad to the router agent. What are some of the attack scenarios that worry you folks at this point?
Well, there are many different points and levels that something might go wrong, right? What I mean is, even if when you build a single agent, right, you need to implement guardrails for all the different levels of before and after I call an LLM, what is happening? Before and after I call an agent, what is happening?
To be clear, in a single agent, as we pointed out, there's one model. Now you have agent to agent. Each agent may be exposed to a model. It's using its own model, right?
Yes, of course. And this makes even further the different the evaluation and the security guardrails even more problematic, let's say. From A2A side, at least, it supports all the different security types, the most common in the market, in order to authenticate the agents, like API keys, HTTP authentication, OAuth2, or OpenID. So within the agent card, the agent can define, oh, look, you need to use this in order to use me, for example. So the first thing about authentication, it is done. Then you need to handle this also. It's like a shared responsibility, the security, right? It is not only responsibility of the protocol, it's responsibility of the developer to make all the different catches of the security issues that we might have in general.
It's equivalent to right now with the MCP, right? So there's thousands and thousands of MCP server. How do I know which one to trust? But at the same time, there's thousands and thousands of Python packages. If I wanna do PDF data extraction, there's 30 Python packages, right? So I have to figure out which one to trust. So at some level, there's some vetting that needs to be done before you actually before you trust another agent. Is that right, Heiko?
Yeah, I would think so. There was this great article a few months ago, I think. The title really stuck with me. The S in MCP stands for security. Um, I thought that was a very clever title. Um, I do believe so we can't speak as much to the MCP protocol as much as we can to the A2A protocol, but I do believe there have been efforts since then to implement authentication methods and security, addressing security concerns with MCP. Um, because enterprises, this is the number one questions enterprises will ask. Without proper authentication and security, you will not have adoption within enterprises, which means you will probably not have adoption at all. With A2A, these, as Socrates mentioned, these concerns were addressed head on. They were basically, it was all built around security because the A2A team understood that in order to get any chance of traction, that built-in security is a priority number 0.
So are you folks familiar with the term, this new buzzword, large action models?
Yes,
Yeah,
I've
yes.
heard the term,
Yeah,
yes.
yeah. So it's this notion that you're going now from your model now is multimodal, can look at screens, environment states. It basically, it can look at your screen basically
Yeah.
and do things.
Within Google DeepMind, we have a project called Project Mariner,
Yeah.
which basically leverages Gemini's multimodal capabilities in order to act on your behalf on your computer screen in your browser.
Yeah, and to some extent, it makes sense. To some extent, obviously, you is something you want to avoid if you can, right? So, obviously, if you can do things that are in a headless way, why would you pretend to be human? You just go directly. If there's some official API or integration, you just go for that, right? But the reality is, many of the tools that knowledge workers use may not have this feature yet. So, how does that impact how we build agents, security, oh, everything we talked about, right? So now that people might start building agents that act like knowledge workers manipulating screens, right?
Yeah, I actually spoke with a online bank in the UK yesterday, and they were very clear that they need to have complete observability on these agents, even if that then means slowing down the process, because just by regulation, they need to be able to explain basically every request that went to the large language model and every action that followed as part of that. So I believe observability is the key in this setup where you just cannot tolerate any errors or very, very few errors. Because it is LLM based, there will still be errors, but as a bank, you at least need to be in a position where you explain exactly what happened.
So with most of the customers, what is happening is whenever they have an agentic solution, they need to share with end users that currently you are using an agentic solution and the way that we're using is like X, Y, and Z. So the legal part, at least in Europe, it requires a legal agreement or to agree with the terms in order to start using that. And all the big customers, they need to be quite clear about this. Now, there are other scenarios as well, because you said about Project Mariner, right? A key example that we want to use also this project is in UI testing. UI, I mean, you have, for example, now testers that they go to your website and they start checking for different bugs, etc. In that case, as a developer, I want an agent to start using my machine and doing all different tests like a human being. Or let's imagine that you have an elder, right? And they have been connected with the customer support of a telco business to fix a router or to fix a configuration. This is impossible from an elder to achieve that, or someone that does not know about technology. So I think the fear is there, like the nuclear energy, right? That we can use that with two different ways is exactly the same with agents and Gen AI in general.
So A2A is a protocol. So at some level, how much, I mean, as a protocol, there's only so much you can do for on the security front, right? Because basically, at some level, that's the responsibility of developers and companies, right? So in other words, if I'm building an agent, I may want to signal to other agents that, hey, my agent is secure because I hired this third party to do, I don't know, some sort of penetration testing against my agent and so on and so forth. So is there a way for the protocol to embed some kind of knowledge that, hey, Ben actually did an extra step here. Not only can he expose his agent, he did something more.
One part that I want to mention is, as you know, a protocol, you cannot handle all the different cases that somebody will use this protocol. That's why A2A team, what they did was to create the notion of extensions. This notion of extensions, you can extend either the data structure that the agent will understand, but also you can extend the methods that, or even the profile, as they call it, that an agent can use. Within this profile, you can say, for example, I want all the agents to use this encryption at business level. And with that way, you can inherit all your systems to use exactly the same patterns. You create the extension once, you adopt that to all the A2A compatible agents, and boom, it is ready to start using that with the same way.
So for our listeners who haven't opened the protocol, how easy is it, right? So someone who's familiar with REST or RPC, is this like a multi-day effort to learn this protocol, or give us a sense?
I personally learned it within, I want to say, half a day. I think, especially someone who is familiar with RPCs, with just traditional internet protocols, this is very intuitive. You have a server, you have a client, and all you need to learn basically is some specific concepts like the agent card that Socrates mentioned earlier. By the way, the agent card itself, just coming back very quickly to your previous question, Ben, could be used, for example, in order to signal not only are these my capabilities, but this is also how I have been tested. You could even think of other metrics. I have an uptime of 99.5%. I have a success rate of 87%. All these additional informations, put it on the agent card or maybe even in an agent registry. Um, you need to understand the concept of a task, which is the central concept within A2A. A task is what the client sends to the remote agent, and then the remote agent will update on this task basically, as defined. So, for example, if 5 minutes have gone by, it sends an update. Or if it has achieved one of the subtasks, I looked at flights, now I'm looking at the prices or something like that, it can send an update. And that's pretty much it. Socrates, am I forgetting something here? But like these are the main concepts.
To add to your point, in order to make also easier to adopt this protocol, A2A already supports JavaScript, TypeScript, Python SDK, and Java and .NET. So this is very important because you don't need to go and implement the protocol yourself. Libraries are already available for you. And this makes everything extremely simple. In ADK, Agent Development Kit, that we use as framework to build agents, within one line of code, we can define a new A2A agent with a business card as well, or agent card as we call it.
So, what is the current state of adoption? Obviously, MCP well adopted. People are using it. People are building MCP servers. So, what is the current state?
To be very honest, I should have probably looked at the the PyPy download numbers for all the different SDKs.
Are you aware of teams or companies starting to?
Yes, I've worked with a customer, an insurance company, actually an insurance platform. I found it rather interesting. I don't know anything about insurance, but the way explained to me was quite interesting. So there is the broker, and then there is the underwriter, and usually those are two different companies, and they were really thinking about having the broker company on their platform build an agent, and having the underwriter company on their platform building an agent, and then having these agents talk to each other via the A2A protocol.
Sokratis, what about you? So, what's your sense of interest, adoption, traction, so on?
The interest is there for sure. 3 weeks ago, I presented in Google Cloud London Summit together with a big customer the integration of A2A into their agentic platform. And we shared with the audience tens of customers that they have adopted already A2A, including also the announcement from Microsoft. And this is not, this is a signal as well that they will start using that. The key part is the example that we started our discussion, right? Many customers, they start implementing agents with all the different frameworks. And at some point, they lack the integration across all the different business units. Now they see the need that somehow they need to get integrated. So the more agents they build, the more need for A2A.
And actually, I should have opened with this. So, in closing, A2A is actually now in the Linux Foundation, which makes it more attractive for companies to really explore, adapt, and contribute to it because it's no longer controlled by a single entity. And obviously, they have a governance that will cut across more than one company. So, decision making is going to be shared across different entities. And with that, thank you, Heiko and Sokratis.
Thank you
Thanks
so
for having
much.
us.